Okay, cool. So in this talk, I'm just going to dive right in, tell you about the things I've been thinking about for the last couple of years since I've been away from academia, and hopefully convince you to work on some stuff that is similar to me. All right. So for those of you who don't know very much about APIs, the promise of APIs for the users is that it's very nice. It's basically like getting served breakfast in bed by a butler. Everybody is very happy. And the promise for the creators is that you get all these people programmatically accessing your system, and you just make so much more money because it is so easy and nice to use your system. Oh yeah, someone asked to enable the video here. Hopefully that is better. But the reality of APIs is it's basically like playing charcoal, fire, Jenga. We read headlines like your Facebook's API is bringing other people down. If you don't get your own API right, it could bring your developer community to great anger. But the situation is that it's very hard to get APIs right. And we'll talk a little bit more about the whole API ecosystem and why that is. So this talk is first going to be about how APIs make programming hard. It's not just the fact that they are APIs, it's like the whole ecosystem and human processes and phenomena around it. And by API here, I mean web APIs, so your RESTful APIs, your AJAX, those kinds of things, although I guess all APIs will count at some point. And then my second part is my, my pitch on why PL researchers like you should also work on the software heterogeneity problem. And then I'll end with talking about why I believe modeling API behavior is the way. And I'll talk about some of the work I've been doing at my company, Akita Software. And if there's anything you want me to pause or elaborate on, please just say so in the chat. And then for a little bit of background about me, this photo is one of my most up-to-date photos that's high quality, unfortunately. So this is what I use. But I was working on programming tools and systems in academia. I was most recently an assistant professor at Carnegie Mellon. I was publishing places like POPL, PLDI, and ICFP, very classic traditional programming languages places. You might be wondering, well, how did a nice programming languages person like you come to work on such messy things? This talk is really about that journey. I came to really believe that APIs were the thing to work on. It wasn't, I actually spent a year trying to get people in industry to give me the right data to work on it from academia. I was having not very much success doing that. At the same time, a bunch of things happened in industry that made me think that starting a company was a good idea. Turned out to be a great time to do that. And so here I am. And so I just wanted to give a really quick photo of my current video setup to share with you what it looks like on the other side. And I originally took this photo to make the point that I'm very serious about Sriracha, but actually my Sriracha developed a gray film on the top, so I had to discard that bottle. But it was there. And a little bit more about my journey to APIs. I started out, my very first paper was about low-level verification. Then I got into how do we enforce information flow security at the language level. I was doing pretty much a lot of stuff at the language level. I realized something though. Every time you called out of the language, you called into something else. And this is kind of the beginning of the seeds of my journey. So I was doing this information flow security programming model at the application level. I built a DSL based on it. I started building a web app based on it. The first thing you do when you build a web app pretty much is call out to the database. It subverted all of my guarantees. So then I had to extend my guarantees to the database. It took 3 years to get that paper published. And so I despaired for a few more years until I realized that maybe APIs are the solution to cross-language kinds of issues. And I'll be talking a lot more about that in this talk. And so, yeah, I think that Something that also I would like to give a shout out to, or someone, is Mike Hicks, who is in the chat. I see him. But many of the conclusions I came to that I'll talk about in this talk are the result of a bunch of user experience research I did at the beginning of Akita. And I'd like to thank Mike for urging me or nudging me to write this up. So there's a blog post. The link was too long to put at the bottom of this, but if you Google this title in the SIGPlan blog, or if you just Google PL perspective SIGPlan, that blog post is there. It was basically Mike co-wrote it with me. He was the editor, but it talks about like how I learned some of the things that led to these views. But yeah, so let's get into it. I'll start by talking about how APIs make programming hard. So I'll start by just describing this blog post that I read that summarizes a lot of what people were telling me when I was asking them what was hard about their lives. And so when I went around in 2018 asking people, hey, when I started Akita, it was a security and privacy company. We've since pivoted to general dev tools. But I just asked people, you know, tell me what's hard about your life. Tell me what's hard about tracking data across your system. And they all said, look, we have, it was basically an information flow security researcher's dream come true, because they said things like, well, when we release data, we don't know where it's going to go eventually. And this is like the motivation of like any information flow security paper. And I was like, whoa, tell me more, because like most programmers said that these papers had wildly speculative intros. And what they said was, well, if you have a really complex system, especially if you have a lot of services, so that's internal APIs calling each other, you everything is organized in a pretty decentralized way. It's not architected from the top down. And so you just don't know what changes are going to break anything. And so what I saw was Shopify is one of the cleaner cases. People were doing all of this pretty intense stuff to figure out when changes would take their system down. And this Shopify blog post, it's APIs all the way down. They have APIs on the inside, and they need to figure out if those APIs are affecting their APIs on the outside. And so they had this really interesting blog post where they talked about, well, if you break the external API contract, you really want to do that with your users only when there are no alternatives or it's uneconomical to do so otherwise. So for a little bit of background, a lot of these APIs are big money makers for these companies, because this is how users use their system. And the more the system gets used, the more they can charge the users. And so if the API breaks, it translates into money lost. And so that's why these external APIs get all the love. But what they're essentially talking about in this blog post is they're manually marking changes as breaking or possibly breaking. They're instrumenting their systems to propagate this information through the systems. And then they will have their developer relations team go out and talk to the users if there's ambiguity. And so here's something that I loved, because they're basically doing a coarse grain taint analysis by hand, and then they're interviewing their users. So it's really like a programming languages researcher's dream come true in some ways. And like there's two ways APIs are involved in this. One is the motivation for this is the external API makes money. And the thing that they don't really talk about is when you have a lot of internal services calling each other, this becomes even harder, which I'll talk about next. And what gets even better from a PL researcher's point of view is that anything is considered a breaking change. So changes to existing error response codes and messages. So this is something that, you know, there have been, there's just been a lot of buzz around like, how do you do error response codes? How do you do things like that? But that's, you know, previously I would have considered a tiny change for industry programmers. But when it comes to APIs, this suddenly becomes important. Modifying the expected payload of webhooks and callbacks. This is just like, you know, did any values change? This is something people have thought about in program analysis for a very long time. And you know, changing the data type of a field, again, you know, bread and butter of PL research, renaming a field, all those things. And so what these people talk about in this Shopify blog is they are manually doing taint tracking to figure out if any of these things happen. And so this was very interesting to me, because if there's one thing we know about software engineering, it's that asking developers to do manual things over and over again is error prone, and that it is a place for automation. But at the API level, there has been a real dearth of automation. So I'll talk about that. Cool. So what I discovered when I dug deeper, and actually many of the industry developers were pretty smart about the shortcomings of automated tools when I talked to them, to my surprise. But you know, what I heard was diffing source code only goes so far when code hits a certain scale, which in this community we all know. This is why we're the PLAS community. This is why we're building automated tooling. But you know, the state of the art for code reviews is source diffs, and that's been falling short. There's also tests as an option, but tests need to cover a lot of ground to uncover every problematic interaction. And especially when it comes to change management in these APIs, tests do not cover like every single error code or every single data format change. And then automated tools was a really interesting case of why they don't give a picture of what's really going on. And something I thought was cool was what developers told me matched everything I'd been despairing about my own work for a long time. Because what people said was, well, static analysis tools completely fall down if you have these large systems for a couple of reasons. One, you know, a lot of companies use dynamically typed languages. That one's expected. But the other thing was, like a lot of these modern API-based companies will have service-oriented architectures. And so what this means is you're not in a monolithic situation, but you actually have maybe up to hundreds, thousands of services or microservices all doing remote procedure calls to call each other's APIs. And so, like I said before, things aren't architected in a top-down way anymore. Things are all calling each other across the network. But the minute you have remote procedure call across the network to a service that has a different programming model and runtime, there is not any automated tool out there that does a good job of modeling it. Like if you had, you know, service calling a service using the same language that you can analyze, there's some hope of pretending it's all the same thing. But what we have is these really heterogeneous, really multi-component ecosystems that are modern systems. And so, yeah, so modern web apps have just been defying the reach of these tools that our community has spent a really long time building up. Because the minute you have this heterogeneity, the minute you have these cross-network calls, it just everything isn't giving you that picture anymore. And so the dream, from my perspective, was to automate software tooling that could fit the heterogeneity of these modern web apps. So I'll just pause here because this is all just background and context. But if people have questions, I don't know how much people already know about this stuff. So if you want me to go into anything here, I'll just pause to kind of get everyone in the same place on context. So Ian asked, how big an advantage is it to be a big org like Amazon? So I have a question about that question. Do you mean in terms of the tooling they have, or in terms of the number of services they have? Because I would say there's an infamous picture. If you Google Amazon Death Star, like Amazon is famously made up of a lot of services. And people like to list Amazon as like the extreme end of, they have so many services, it's really hard to do anything. But they also they also have a lot of really good tooling. But I think Amazon also doesn't have like nobody out there, I would say, has really truly great API level tooling the way they have language level tooling. Like I see. So Ian says, okay, so does Amazon have the kind of tooling that would solve this problem? So yeah, I would say no. Amazon has amazing tooling for, like, you know, their TLA plus verification, verifying their hardware hypervisor. I don't know exactly what they verify. But I think that no company really has solved this service interaction, mapping everything out problem. I think if you're in a single org, you can like dictate that certain kinds of tracing libraries get used or something so that you can do this. But one reason that I chose to talk about this topic to you all is I think there's a ton of open problems in distributed tracing, in modeling like the behavior of these distributed systems, essentially, that are languages problems that we can solve together. Cool, great questions. So yeah, I would describe API efforts in the present day as if you have an external API at companies with the resources to spend on tooling like a Shopify, a Stripe, or a Twilio, you get some love. So what I've seen is like LinkedIn, for instance, uses their own framework to generate their API documentation, or Shopify has their change management framework. But in terms of mapping everything out and really having a handle on everything, like these are hard unsolved problems that I haven't seen anyone solve. Maybe Amazon secretly has been doing it. But actually one of our team members, Cole, came from Amazon, and he was like, oh, hey, I encountered a lot of these problems when I was trying to do cloud engineering at Amazon. So for Amazon specifically, I don't think they've solved this problem. And so everybody else is left in kind of a parking lot with weeds. Like the state of the art of API tooling, I would say, is pretty, it's pretty Wild West in early days, which means to me, it means there's big opportunity to have an impact. And so, yeah, now here is my pitch for why PL researchers like you all should work on the software heterogeneity problem. All right, so first of all, more and more software is APIs. And so according to the Rapid API Developer Survey, if you're in a 5,000 to 10,000 person org, your average number of internal APIs is in the hundreds. And so, a lot of companies have one external API, and maybe you can do like some frameworks and some like, manual propagation of changes to handle that. But once you get to internal APIs, like pretty much no one has good solutions there, which means it's a great opportunity. So I put the Netflix Death Star here, but there's also Amazon has a Death Star. Uber has a pretty good Death Star. There's some really good Death Stars out there that basically look like this. But yeah, there's a lot of complicated stuff out there, and no one really has a good solution. And like I said, I spent 3 years modeling just one edge of like a two runtime interaction. So I spent a lot of my PhD actually despairing, like how are we going to solve the problem of modeling this heterogeneity? Because what I saw was modern web systems are not just your application, but you have maybe you're using Node and Python, and the bigger you get, the more language runtimes you're using. And then you call that to a database, but then you might use data streams, different kinds of data stores for different kinds of problems. So even if you have a monolithic web app, but you're calling out to Redis, you're calling out to maybe Kinesis, there's, that's 3 runtimes right there already. So just to give an idea of the pain I suffered, here's the math that took us 3 years to get right for just like, a application level, like Lambda calculus plus SQL, and extending our information flow propagation there. And so in the chat, Mohit said he's a little confused about the difference of internal and external APIs. So that's a great question, Mohit, and I've kind of been hand waving over it. So I would say, like, at a theoretical level, there shouldn't be a super big difference, but because of practice and because of the different importance people place on internal versus external, there are differences. So like from like a first principles point of view, internal and external APIs, they're all APIs. From a practice point of view, they're slightly different, but not for reasons that actually impact any of this conversation. So one is like external APIs tend to be using REST Open API more. Internal APIs tend to be gRPC more. So there are like some differences there just with the technologies, but then in terms of the amount of importance given to tooling around it, I would say that is where the biggest difference is. So for external APIs, usually that's where the companies make money. And so they're like, like any bug in an external API like loses the company. You know, they measure, like our product manager at Akita was at Twilio before, and I think his scope was like less than 10 API functions, because each function was like, some millions of dollars of like that you could make if you improved the API just a little bit. And so for these external APIs, you can imagine they have like, many PMs on a whole API, just optimizing the heck out of it. And then in terms of developers introducing breaking changes to those APIs, you bet they're conservative about things like that. You bet if they have, they have 10 chips to spend on any kind of API tooling, they like put that on their external APIs. So if you're a company with a lot of internal APIs, what happens is you don't get any of those chips spent on you. Whenever APIs update and there are breaking changes, they might affect you, but nobody really has put in the effort to prevent those from happening to you. And so it's much harder. And then Gerben asked, internal APIs, providers and callers are owned by the same entity. Yeah. So what I mean when I say external API is it's like the customer facing API versus the internal APIs are the company's own APIs. And then I might say third party API at some point, and that's your company's API calling out to Stripe or Twilio or another API. And from a modeling perspective, they're honestly very similar, but from importance and like where you fit into people's tooling perspectives, they're pretty different. Yeah, great questions. Thanks, guys. And so, what I discovered about why automatically analyzing web apps is hard is because, first of all, you just have many software components. So within the company, you have, hundreds, thousands, potentially, of services all talking to each other across APIs. And then they're often running in different runtimes. Sometimes they're black box. So any third-party API you call is going to be black box. And then even for your company's internal APIs, there's no guarantee that you can see inside of it. It might be super legacy. It might be some team all the way over there. And so this is what I call the software heterogeneity problem, because modern web architectures defy both application level solutions. So if you think about one metaphor I like to use is these modern web apps are like ecosystems. They're like rainforests where you have birds and trees and animals, and they're all interconnected. And if you have application level analyses, they're really operating on like one bird or one tree. It's not telling you about the relationship at all. And then network level solutions, they're kind of telling you this is how the bird interacts with the tree, or this is how this tree interacts with that tree. But if you want to zoom out and get this whole picture, kind of like what Ian was asking, nobody really has that picture very fine-grained yet. And I would say that a lot of the people working on this have been taking a systems or networking perspective. The thing that I think is really special about programming languages is we're all about semantics and we're all about structure. And this is a problem that definitely can benefit from a lot of both. Cool. So the result these days is developers do a lot of manual work. So today it's expensive for developers to understand the impact of their code changes on others. And it's hard for developers to understand the impact of other people's code changes on them. And cool. We have this question from Ali. How much of the problem is that each system is stateful as opposed to functional? Yeah, that's a really good question, Ali. I think that, so if I'm understanding correctly, you're asking, like, is it the state of each system that we need to update, or is it like some kind of functionality? So let me think about that. I would say that the big thing, and so like, I will not directly answer this question, and maybe you can draw conclusions in the chat yourself. I would say that the big thing that is not understood is, from my perspective, the interaction graph across the APIs. And so like this is how system like service A interacts with service B. This is the endpoint that service A uses to call service B. This is the kind of data that service A uses to talk to service B about. And I think that like the interaction graph is really about who gets to update whose state. And so like, I don't know if you consider that functionality. It's because I think that like a lot of the functionality is encapsulated inside of it. And so maybe my answer to Ali's question is that it is a very like stateful thing, but it's really about the communication and like who gets to update what state, if that makes sense. And then someone asks, is it because the paradigm of microservices that lead to so many APIs in an enterprise? Yeah, so microservices are a big part of this. But like I said, even if you don't have microservices, just the proliferation of different runtimes, like even if you have a monolith and it talks to Redis and Kinesis and some kinds of different data streams and stores, then you start to get this problem already. I started to see this problem when I had like, you know, my Python application talking to my SQL database, and I was like, oh no, if we have one more runtime, we're starting to have trouble reasoning about things. Ian asks, leading question, why is it not enough to take my Kubernetes spec and analyze that thing? If I have some sort of spec which orchestrates all of my small microservices, what can I do with that? And what can't I do with that? That is a great question. And so one of the things that I discovered after, well, I started discovering it actually the year before I started at CMU, which was the limits of static analysis. So a side note is I spent a year in a biology lab the year before I went to CMU, and we were modeling protein-protein interactions, which are also like asynchronous, like huge distributed systems, basically. And what I learned was if you use static analysis, the only thing that you could do essentially was dead rule elimination, like which proteins never affected any other proteins. But if you have this like huge distributed system with a lot of like asynchronous things happening, what you really want to know is what are the paths that are common to take and how common are they? And what are the paths that are not common to take? And I would say microservices are really similar. And so there's tools out there called APM tools, application performance monitoring. And what they will give you is that, like essentially a static graph of how all of your APIs are connected. And I think your Kubernetes spec will essentially tell you that too. So it'll tell you, my guess is it'll tell you most services talk to most other services, and it's not that interesting. But it's, I would say the fine-grained dependency analysis, and even like down to like implicit contracts of like invariants of your APIs that you really want to know. And those are pretty dynamic properties. And when I get into it a little more, like maybe you'll see the difference between like this is anything that could call anything versus this is what actually calls what. And why this is related to security. So like I said, Akita started out trying to help security teams. And what we realized was security has a really hard time detecting potential issues, prioritizing issues for developers to fix, and communicating with developers about how to fix these issues. And like I said in my blog post, when we unraveled deeper, it was that developers didn't really have a handle on this to begin with. And so no wonder security didn't have a handle on this either. But I think that the nice thing about being a programming languages and security researcher is that you can help with this exact problem. Basically, like how can security help developers identify potential issues, prioritize potential issues, and then communicate about the issues to fix. Cool. So now I'll talk about why I believe that modeling API behavior is the way. And so I, spent some years despairing about the software heterogeneity problem. I spent some time seeing other people despair about the lack of order and the abundance of chaos in their modern web environments. And so then I was like, okay, cool. If we want to model these modern web environments, what we need is a standard way to describe what each service does. So some way to encapsulate functionality. Back to Ali's question, which I think I only answered kind of halfway. We can talk about it after. We need a standard way to talk about how these services interact. And then we need ideally a way to connect specification to the code if we have specifications for all of this. And so, you know, this is like pretty standard modeling 101. But something that I realized that was very cool is that there has been pretty massive standardization among API protocol languages. And so I actually didn't realize until a couple of months ago that this was not inevitable, that it was the work of a lot of people who tried to standardize this. But there has been standardization around things like OpenAPI, Swagger, gRPC, Thrift, and GraphQL. Like you pretty much, I guess there's also like SOAP and WSDL, but in terms of modern APIs, you just don't really see anything else. And so this was really cool to me because I was like, hey, there's a specification language. It's somewhat semantic already. And so what we can do is we can use this to start building up our models, because an API, like an API encapsulates functionality. And so the API spec is a specification of that functionality. The interface is how communication happens. So it is a standard way to talk about how the services interact. And then ideally, it should be tied to the code as well. So if only we could do that. So our insight was, hey, look, we could just potentially analyze API specs and traces instead of programs and program traces. And this lets us lift up one level and potentially get a lot better information about what is going on. And so there's a catch though. The catch is that APIs are not always easy to come by. So there's a survey done by Smart Bear, an API company, that says only 35% of API providers feel that their organization's API documentation is above average. And so if you think about how like almost 100% of parents think their children are above average, like this means the state of API documentation is pretty bad. And there's a reason for this. So right now, API specs are not auto-documented. So there are tools like Postman and Insomnia that let you like poke at your APIs manually. So Postman, I would say, took curl, built a beautiful UI around it, built sharing around it. But at its core, it's still you're curling. There's not a ton of automation on top of curl. And then, like I said before, there are libraries that people can use and frameworks to auto-generate documentation, but it's often only used for the external APIs. It takes work. People aren't using it across like all of their internal stuff. And so that brings us to the challenge that we've been going after, which is how do we automatically model API behavior with as little developer effort as possible? So like no frameworks, no lines of code changes if possible, no proxies if possible, because those are invasive in production. But yeah, so our challenge we set out for for ourselves a couple of years ago was, can we have the developer basically do nothing and still start characterizing what the APIs are doing so that we can start characterizing this interaction graph across the services? And Ali asks, how are API specs different from program specs or ADT specs? That's a really great question. I think that APIs are like, we can think of it as a kind of program spec that's one level zoomed up. So like I would love to think, so APIs right now aren't really functional specs, but I'll talk a little bit about where we want to go and what we want to model on top of APIs. And I think that like I think we can start thinking about APIs as like kind of like an abstracted program spec in the limit. Cool. So yeah, so our solution was, hey, let's just apply PL techniques that we know and love to API modeling. And so, you know, we've seen things like invariant generation before. Why not apply that to API traces? We've seen example-driven synthesis before. Why not apply things like that to API traces? Type inference. So if you looked on our blog, that's already something we've been applying at the API level, finding data format and type issues at the API boundaries. Trace-based analysis, I mean, that's basically the same as invariant generation to us at this point. And initially how we got started down this path was we were trying to build an API-based fuzzer, because we wanted to exercise different parts of the API. But then we were like, whoa, this is super interesting. You can do a ton of stuff with this. And fuzzing APIs is pretty clean. And so there's also a lot of automated testing you can do with APIs to kind of inject values, see where they end up, and do black box data flow analysis. And so that's something that we've been getting into as well. But yeah, this slide is both like, this is what we're doing, but also I hope I can entice you all to see the API layer as something, somewhere that you would like to live as well. Cool. So now with the time I have left, I'll introduce a little bit of what we're doing at Akita, give a quick demo, and then there have been great questions in the chat. So I'd love to just kind of have a discussion with whatever time we have left. But yeah, so what we've been working on is helping developers get a handle on their API graph. So we've been dynamically modeling API behavior. So with no code changes, no config changes, analyzing API network traffic to build API specs plus. So I'll show you what we're able to do now and talk about where we're going with that. We believe that one of our killer features is diffing, because once you capture a behavior model of an API / service, you can diff on those. So you can diff across your pull requests, you can diff test versus production, you can diff production versus production, you can diff everything against the handwritten spec. And so like, to me, that's just like, that's super cool. And so I think like back to Ali's question, like, I think we can treat API specs the way we treat program specs. And like, if where I want us to go is basically get finer and finer grained API specs so that we can really model at that layer. And then where we want to go is uncover the underlying structure of the API graph. So I know Facebook is kind of canceled right now, but I think Facebook did a really cool thing in terms of making explicit the social graph of interactions so that you can know all of your friends' information just by going to one place, and you can broadcast to all of your friends just by going to one place. And I think for APIs, that's like, that would be something that's really cool to have. And there's also some massive technical challenges to overcome before we get there. And so this problem is interesting to me, not just for where we can go with it, but for the super cool problems that we would need to solve along the way. So I'm just going to give a really quick demo. I'll show you Akita generating an API spec. I'll show you some of the fancier things that we're starting to build into these specs. And then I'll show what happens when we make a code change, how we start catching issues there. So cool. What I'm going to do is, so Akita just runs as a command line agent. So I'm just going to throw up a Docker container of a test service really quickly. It's a little file sharing system called AkiBox. It's like a little Dropbox. You have users, you have files, things like that. And then I'm just going to start running Akita. And how Akita runs is you just initiate it from the command line. It starts listening at a port. And then what we can do is just generate some network traffic. And Akita, so there's two ways Akita can generate specs. It either uses BPF filters and listens to your network traffic, or it takes what's called HAR files, HTML archive files. And we're doing the first way right now. But here we can go here, just say, all right, we're done. We're ready for you to generate a spec. And so let's go over here, type in the URL, and there is our spec. So right now we generate only open API specs, but the other protocols are in our roadmap. And what we just did here is we watched network traffic and we generated an API spec. So here we can see these are the different endpoints we called. And Ali, maybe this will answer your question a little more. Is an API spec like, can we think of it like a program spec? So what right now an API spec does is it describes the endpoint and it describes the data types each endpoint takes. So the way I guess you can think of types as program invariants, an API spec is like a type right now. Normal API specs do not have this. But what we started doing was we started doing more advanced type inference on top of the API spec. So here we're inferring specific email formats. So if you have any changes here, we actually will let you know. And then we started inferring related types. And so like if we see the same type come out of one endpoint and go into another one, we're actually mapping that out now. We don't have a visualization yet, but for our automated testing, we needed to infer that. So we have that information as well. And we're inferring specs not just for your incoming traffic, but your outgoing traffic. So if you have a service, stuff talks to it through its own API, and then it's talking to other things through other APIs. So here we list the other APIs that we saw the service talking to, so you can start building up that graph. And then we have a basic insights console that we're showing. We're still trying to figure out like what people want to see here, but we're able to summarize what data types we saw, sensitive data formats, status codes, and things like that. And this is really just the beginning of what we're hoping to infer. Like right now we do types, but implicit contracts, so relationships and invariants between API arguments across API calls. Those are all things that we're really excited to work on. So I'll also make a really quick change and show you what that looks like. So I'm going to make a branch. That's the plus demo branch. And then this is AkiBox again. What I'm going to do is I'm going to uncomment an endpoint that registers a phone number. So what this is doing is it's adding an endpoint that it's the only phone number endpoint. And so what the eventual GitHub comment that you're going to see shows is you have a new endpoint and you have a new data type. And so I'm going to uncomment this here. And then what we're going to do is make a commit, adding phone number, endpoint. And then we're going to make a pull request. Cool. So now we've integrated this with Circle CI and GitHub, so that there's a GitHub comment now that summarizes this is what changed about your system. What's going to show up here is a summary of the change. But right now it's running the new test, and then it's going to compare against the old tests. So that'll take a little bit of time. So in the meantime, I will answer this good question by Ian, which is, what if OpenAPI isn't expressive enough to capture the information you care about? For example, I implement increment a counter. How can I infer that behavior? How can I check automatically that the spec is violated when I change? Do we need more precise specification languages? So that's a great question. I'll show you how we're encoding additional information now, and you can actually use the same trick to encode anything else you want. So in your API spec, you can add basically other fields that you look for. So this you'll see is not really a normal API field. This is an Akita format field. So we have these X Akita format fields that are essentially vendor annotations where we stuff additional information. So this is just JSON saying, in the formats, there's this special kind of format, the kind is email. And so that's JSON that we specified. So what you can think of here is any kind of specification language you want, you can encode it as a special annotation with JSON. And as long as you're consistently generating that every time, you can diff on whatever you want now. And so side note, I had one internship where my entire job was taking the last step of proof carrying code compilation and stuffing proofs into bytecode. And this really reminds me of that. So if we think about the API spec as kind of like the bytecode of our microservices, you can stuff any kind of proof into the API like this using JSON. And if it's big, you even do compressed stuff. There's you could do anything with this. But yeah, that's a great question. And so back to our comment here. We have the summary, 1 endpoint added, 4 endpoints changed, 1 data format added, like we saw. And like I said before, like this is just the beginning. Data formats were like step one for us. Where we want to go is like, you know, implicit API contracts. Like there was, for this kind of country code, you expect these kinds of arguments, or you have this specific relationship between your API functions, or, you know, you only ever have this optional argument when this other argument exists. And so for those kinds of things, to answer Ian's question, they can all be encoded right here. Cool. So I'll try to go quickly so we have some more time to discuss. But essentially how Akita works is we observe traffic, we send metadata, so we send request response information to ourselves. That's all our traces need to do anything. And then we do analysis over those traces to generate everything. So we don't need to see any sensitive data because all we need is the metadata. And then a big thing that I learned when talking to developers was that integration friction is key. So we've spent a lot of time working on our integrations. But yeah, so in terms of what you can all work on, I listed out some possible research topics. Type checking at the API level, I think you would have to figure out what's an interesting problem there, or what would be you know, sufficiently interesting methods for you. But that's definitely, I would say, an open problem. Invariant detection within API calls, we're starting to do some basic versions of that. But we welcome people to do more advanced work there because we know we're going to need it one day. And so if you already have it done, that's great. Invariant detection across API calls, similar. Black box data flow techniques at the API level. That was kind of how I started down this path. But I learned that black box was very important for some of these because of the integration. And so black box techniques that have to do with APIs are great for adoption. And they're also super hard because like they're just harder to do than white box or gray box techniques. And so if that's something you want to work on, I'm happy to talk more. And then automated testing at the API level. So Patrice Godefroid has a couple, I think like 3 now, really great papers on automated testing at the API level. Kaushik Sen has some really great work there too. Marcel Bem, there's a lot of research already there, but in this community, this is definitely something that I encourage people to work more on. And for all of these, I didn't cite papers for others of this stuff, but there's definitely really good work already there. So cool, yeah. I hope to convince you to work on APIs with me. Like, if not directly with me, I'm happy to talk whenever, but I just think this, like, there's really cool problems here and they're hard. So yeah, working at the API level is, to me, a great way and the best way to handle cross-language, cross-runtime issues. Those plagued me, and they were really the source of my existential crises for many years. And so APIs were the solution for me for that. I hope I've convinced you you can apply a lot of interesting programming languages techniques, and that should be software engineering techniques at the API level. And yeah, I think developers are really hungry for tools here. So I think the adoption potential is higher than for maybe some other stuff. So yeah, thanks guys for the great questions, and seems like there are more. So I will continue answering questions. Please keep chatting them. So Rachel said, Akita feels useful. Can you talk about how this tool is helpful specifically for security and privacy? Yeah, that's a great question. So initially, how we got started on APIs was people were like, hey, can you be black box and tell us where our data is going? And so we started out building a security, like a data flow fuzzer, essentially. So we were doing sentinel testing, like injecting unique data into APIs. And then we realized we needed to fuzz it to get a little more coverage. And so like through that process, we realized that like everyone said, oh yeah, if you could do that, that's cool. But we don't know what APIs we have. We don't know what data our APIs have. We don't know how to talk to our APIs to begin with. And so in terms of security and privacy, I think like endpoint detection, endpoint discovery is something that security teams have just like already a lot of problems with. So like, I don't know how interesting that is to the PLAS community, but like that's a very basic problem that we're hoping to help solve. Another one is data discovery, like at the API layer. So like what data types are people using at the API, if we can automatically identify those. That's also something that's useful. And then our automated testing, what we're doing with that is data, like essentially black box data tracing. So we're like, like an example of something we can do is inject a unique password and like, well, okay, so like you probably shouldn't be doing password through your API, but let's say maybe inject a unique phone number in your phone number API, see where that phone number ends up in your logs, in your output channels, in a bunch of other stuff. And then we can start constructing the map that way in a black box way without having to do taint analysis or something like that. But yeah, great question. Yeah, because one thing, like I kind of glossed over this in terms of like integrations, but one thing we learned was, especially for security teams, what we learned was security teams have like very little social capital to get developers to integrate them. And so we got very into API-based and black box techniques because of that reason. So Ian asked, what about abuse of APIs? A ticket service detecting that a bot has discovered their things. Oh yeah, those are great. That's a great question. That's not something we're working on, but you can imagine if you have like an invariant detector at the API level, you could do some really interesting abuse work. So Martin Reinhardt at MIT has a system called Clearview. I don't know if you've heard of it, but essentially what they use is they use the DICON invariant generator to learn normal behavior of the system. And then they got a DARPA red team to come and attack their system. And they were able to use anomaly detection to, they were able to use their invariant deviations for anomaly detection. And so I believe that the same techniques could be used for things like this. I haven't seen it tried, but if this is something you want to work on, I think that's a very good idea. I think it's very interesting. But yeah, I think that something that I saw is a lot of the techniques in this space are very AI based. And I think that programming languages techniques like invariant detection are actually extremely useful. So Clearview is one paper to read there. And then Facebook has also an invariant detector that I think is very good. So Ian also comments that if you're collecting API traces, you can machine learn all the things. So my counter to that is if you look at Facebook's invariant detector, it's basically like, well, it's literally a counter. My counter is that you can use a counter and not machine learning. But yeah, like I think that like if you impose the right structure on some of these problems, you can do better than like the like unsupervised or like the pretty like non-structure oriented machine learning techniques that a lot of people are using in these spaces.
There's also a question in the Q&A. Kevin Morio, do you think GraphQL can help in improving the current API landscape?
Yeah, that's a great question. And I think that when we started our API journey, we thought that people who use GraphQL seemed like they knew what was going on because they have this self-documenting thing and it has so much structure, et cetera, et cetera. But what people have been telling us is that there are a lot of hidden problems with GraphQL. Even if you have something self-documenting, you can still have change management problems. You can still have type errors. So like even if you use GraphQL, you still have like hand documentation of some things, and so you can still have type errors when you're interfacing with your actual thing. And so yeah, I think that GraphQL is not something we have spent a lot of time on, given that it seems lower hanging, like there's like lower hanging fruit for us right now with non-GraphQL stuff. But definitely, yeah, there's I think a treasure trove of hard problems to solve, even if people are using GraphQL.
Is there any chance that so when I think of an API, I think of something like OCaml, right? That the MLI files.
Yeah.
And so that's why I think there was a little disconnect for me at the beginning of your talk, because you're taking something that's lower level and inferring that structure. I mean,
Mhm.
trying to infer that structure. So is it possible that the web API could have more of that explicit?
More structure.
Yeah, I mean, yes, that you could, instead of having to infer these things, that people could specify them.
Yeah, that's a great question. So I think I'll say there's been one nice thing about web APIs, which is that they're so simple. Like they impose such a they coerce such a simple structure that they're actually very easy to analyze in terms of like everything has to be like a get or a post, or there's some like signaling that makes it easier. But then in terms of would people write more specifications on top of their web APIs? In terms of what we've noticed, I think that GraphQL, for instance, has convinced people to write more specifications because they're getting something out of it. So it seems like if you design something that can give people automation, so if you're like, hey, here's a new API format that like will make A, B, and C much easier if you give us the spec. That seems to be the way to entice people to add more structure. But in terms of like, what we see for documentation right now, a lot of people showed up to our beta because they don't have documentation for their HTTP REST endpoints. And that's partly because they're not getting very much from their documentation. Like all they're getting is somebody else, like it's like they're helping other people use their thing. But I think it seems like helping oneself do something faster is a much bigger motivation. So in the hierarchy of things that motivate people, I think like if you're like, hey, write this spec and you can like end your day sooner and like, go play video games, like that's like the number one thing. And then if you're like, write this spec and other people will have an easier time, they're like, I'll do it later. And then, I think
yeah.
Oh, sorry.
I was going to say we're almost out of time.
Yeah, and then like the next lower priority is write the spec and your code will be more correct. Like I have not really seen people step up to that. And then I guess I'll take one final question, which is where can academics find realistic benchmarks to study the security and privacy of APIs? That's a great question. And actually, Cole and I on my team are striking up a collaboration with a couple of academics, or we're trying to, where we realize there's not great benchmarks, but there are some great publicly documented APIs out there, like Slack, GitLab. There's a few that if you reach out to me, I can try to think of it, but there's not like academic benchmarks around it, but there are public APIs that you could potentially work on if you're interested.
Okay, so thank you so much for your talk. This was very stimulating.
Yeah, thank you, Ali. Thanks for the great questions and discussion, everyone. This was really fun.